Welcome back to Water. And I have two guests, Dave Dubois, state climatologist, and Tom Schmuggy, Mr. Remote Sensing of Water. So we had just gone through a number of pieces of news and projections and methods that are being used to estimate the water budget for our state. So where do we want to go from here?
I would like to make a comment on a paper, a recent paper by a group from University of New Mexico, looking at the energy requirements in the oil industry for getting their water. Right now, when they do their fracking, they get the water mostly from groundwater, and they use reasonably good quality water for that. But the whole process of getting oil and gas produces a lot of water called produced water. I've heard the term that 7 times the amount of oil that comes out of the ground comes up as of water as what they call the produced water. This paper quotes that in 2015, I believe it was, the water that they required for fracking was on the order of 23,000 acre feet.
In the state of New Mexico.
In the state of New Mexico, for all the different oil and gas regions in the state. And the produced water that they got was roughly 3 times as much, 73,000 acre feet. And so what they're proposing is that they take this produced water and treat it to get it so that it is of a good enough quality for them to use in fracking. And their point is that they looked at the energies involved in pumping up the groundwater and then transporting it to your fracking site versus treating the produced water and then trucking it to your fracking site. And they found that it's significantly less, so that it would be significantly less expensive or less energy intensive to treat the produced water and use that. And it would be a savings on the good water that's in the ground for this purpose. So it was a very interesting paper. It's produced by a group mostly at the University of New Mexico.
So they're talking about bringing it up in quality, not to drinking water standards, but just,
Correct.
Well, I did an interesting study on contract with British Petroleum back when. This was before Deepwater Horizon. They have a lot of produced water everywhere, but this particular study was at Baku, Azerbaijan. And they were running out of places to store their produced water. So somebody at the company said, let's consider evaporating into the air with these thing called land sharks. And they just blow it in so it evaporates. So I engaged Junming Wang. Do you remember him? He was a postdoc here with Ted Samus. And I did the model of the initial injection, and he did the model of the transport. So BP was very interested in, does it meet environmental regulations? Because it has benzene in it. It has particulates, particularly like insoluble ferric hydroxide precipitates and so on. The interesting thing is, if you looked at the dispersion, it didn't have a problem with the benzene standards. And British Petroleum said, look, we'll meet the stricter of 2 environmental regulations, local and British. We said it's really the particulates that are the problem. We said don't do it, and they didn't. So that was very interesting.
What kind of particulates? It was how were they evaporating it? Just in the air?
Oh,
they open it
well,
up?
if you blow it into the air with one of these land sharks, then it...
what are land sharks?
They're just giant fans with injection of water.
Oh,
so
okay.
you
So
just
the
take
spray.
the water,
You're talking about
you
spray.
spray it into the air
so,
and let it evaporate.
Yeah. Because there's probably a lot of there's solids in that. That's probably why it didn't pass
it's
dissolved solids.
There's a lot of iron, insoluble iron compounds.
Yeah, they have it. I mean, that's kind of one of the permitting for the power plants in New Mexico is when they do evaporation. There's, they have a standard on how much solids
Oh,
you
mean
can
like
have.
the wet cooling towers?
The wet cooling towers, yeah. Because you could, when you evaporate that, then that produces particulates in the air, unintended. But and I actually worked at a nuclear power plant, and I remember there were some solids, and it was one of those big cooling towers, and depending where you park, you have your car covered with all this white material.
Well, I did another interesting study. It was all modeling, basically, about water use in cooling for thermal power plants. And I guess it was claimed at one point that 20% of water diversion was for power plants nationally. Well, it's diverted, but only 10% of that is consumed when you work out all the stuff. If you have a heat cooling by rejection to surface water that's then recirculated, you raise the temperature, you raise the evaporation downstream. So overall, it comes out to more like 2% of water is actually used for cooling power plants.
Yeah, and that brings up the topic of vulnerability. Our energy sector is vulnerable to global warming, plus the short-term drought cycles. I remember being at a meeting in Texas in Fort Worth, and there was a bunch of utilities there, and they were basically saying, this was like in 2012, when it was really dry, and they were very concerned that their intake of their water for the power plants was just was very close to the limit, where they couldn't use that power plant anymore if the water was any lower, and they had no other source of water to put there. So it was like, wow, that's not good. When we're having in Texas a huge exporter of power. I mean, there's a lot of power plants, And
exporter, really, because they're on a separate grid.
Yeah,
and they don't.
They have a lot of users, but then a lot of it goes out too.
Yeah.
I mean, there's some really big energy sector.
Well, look at Cape
there.
Town, South Africa, right?
Yeah.
Did they shut off the taps?
I don't think so yet,
Not
but
yet.
they're close.
Close, yeah.
It's a case there where they are relying on surface water for all of their municipal water, and the drought has just hurt them.
It's like 5 years of drought or something.
Right, and so now they're, I guess, probably looking at desalination, but that doesn't come on quickly,
No.
or using groundwater, and it'd be an interesting problem.
Yeah, what's the prospect for desalination as economically and energetically sustainable? I know El Paso does it. Right?
Yeah, I think there's a lot of people working on this. It's not as static by any means. I know at the Water Summit we had some presenters there that had did some small scale out of the country, and they were solar powered. So and they need to be renewable in order to adapt to whatever you put these things.
Right. El Paso is using fossil fuel electric power and reverse osmosis, which is a lot more efficient than distillation.
Yeah.
But you're using more power. I guess you have to say that electric power utility use of water to generate the stuff to drive this desalination is less than the water you're going to produce.
Yeah, but if you have the power, that's the problem.
If you
Do you have the
power.
power? A lot of these places don't have the power.
Yeah.
But I guess El Paso, the problem that I've understood with desalination in this area is, what do you do with the effluent, which is water that's twice as saline or contaminated?
10 times. El Paso pumps it 26 miles away and injects it into the ground.
I also thought I heard that they were able to sell it to somebody who would extract the chemicals out of it.
Really?
That was another possibility that they were looking
Yeah, next
into.
door, I think, right? There was a company who was extracting all
Really?
the salts and the various metals and then using... So that was another business. Somebody's downstream.
But that takes energy, too.
That takes energy,
Yeah,
right.
yeah.
True.
But if they can break even,
Yeah.
maybe, I don't know, maybe, eventually they can go off the grid or something, or I don't know. I mean, that's...
But, like here, what would we do with the effluent? I mean, if you pump it back into the ground, you're making the groundwater worse. So it is a problem.
Yeah.
Well, what about our aquifers? Are there... I thought most of New Mexico was underlain by brackish water aquifers, and not terribly.
Probably true, but I think ours in the Mesilla Bolson is generally pretty good, and the upper layers of it anyway.
Right.
So the ones, obviously the ones that are being used for irrigation and for municipal water are pretty good. And it's quite there's a considerable amount there. Now the question is, if we keep pumping it at the rate that they use for irrigation, whether it'll be able to be recharged enough to maintain it.
Right, and then you can't deplete it more than, I don't know, a few percent before you start getting land subsidence and other problems.
That was an interesting, one of the charts that was in that City of Las Cruces plan showed just that, exactly that problem, showed the variation of the, where the water table was and the depth to which you could extract the water before you have a problem with subsidence.
Right.
I don't know how they determine that depth, but it's a significant, it looks like there's a significant layer that's available for extraction.
Uh-huh.
And isn't there in some areas there have different recharge rates?
Oh,
some of them
certainly.
is very short-term response to drought cycles, but then there's some that are like 3,000 years. I think somebody mentioned that at the summit.
Probably for the Ogallala or the High Plains aquifer is, my understanding was that it is really what they call fossil water that's been laid down for many years ago. And so it's that's another case where Texas seems to have pumped that one almost dry and sucked the water out sucked the water out of New Mexico. So I don't understand their claims.